So for this lesson, you're going to need your protractor and possibly a straight edge or ruler, but you just definitely need to make sure you have your protractor. You don't need your compass for this lesson. Okay, so beginning. So 5.2 angle bisector and perpendicular lines. So we have already, we've already talked about angle bisector. So if you didn't get that written on your vocabulary sheet, make sure you get it now. So it's a segment, ray, or line that separates two halves of a bisected angle. So you're basically cutting an angle in half. We have already done this using our compass. Okay, so remember, you put your compass point here, make an arc, put your compass point on the intersections where it gets the legs or rays of your angle, and make an X in the middle, and then you connect here, and then this is half your angle. Here's the other half of your angle. Okay, so cutting your angle in half, creating an angle bisector. Now we're going to do that today with a protractor instead of using a compass. So the steps are a little bit easier. So basically, first we measure our angle. So measuring this angle, so 0 to 60 degrees, this angle is 60 degrees. Now, dividing that by 2, I get my angle bisector is going to be 30 degrees. Now, with our protractor still lined up properly at our vertex, at the vertex of our angle, measure 30 degrees. So 30 degrees here, and then draw a line from the vertex of your angle to the mark you just made where your angle bisector should be. So bleh, line, and that's it. There's your angle bisector. Okay, then you could use your compass to double check, make sure that this is 30 degrees and this is 30 degrees, cutting that 60-degree angle in half. Okay, so example 1, bisect the given angles using a protractor. So first off, take our protractor and make sure it is lined up with our angle. So taking a look here, make sure it's properly lined up. This is about 52 degrees. So my angle is about 52 degrees. So I divide that by 2 to find out what my angle bisector will be. And I get 26 degrees. So then with my protractor still lined up, 26 degrees. So here's 25, 26. Draw a line there. So 26 degrees. And then taking a straight edge, or I can use this guy again actually, but I'm not going to because it sucks using it on this thing. You draw a straight line from there, from your vertex to your line you just made. Then you can double check and make sure that your angle bisector is correct. So it kind of sucks. It really sucks to do on this application, but you get the deal. Okay, so here 26 degrees and 26 degrees. So there's your angle bisector. Next one, same thing, line her up. Okay, so lined up with 0 there, and taking a look, so 0 all the way up to 120, about 120 degrees. So divide that by 2. My angle bisector should be 60 degrees. Okay, so here is 60 degrees right there. That'll let you. And then from your vertex to your line, and then you could double check with your protractor to make sure that each of these is indeed 60 degrees. So there, that's 60 degrees, and scooching over. Oh. There, also 60 degrees. 60, 60, so this is my angle bisector, right? Go away. So question number 2. An angle is bisected. Each resulting angle is 38 degrees. How big was the original angle? So this is starting here, so at our bisected angle, and figuring out what our original angle was. So in order to find our angle bisector, we divided by 2. or yeah, so in order to find our original angle, we will multiply by 2. So 38 degrees multiplied by 2, and I get 76 degrees was my original angle. Question number 3, the angle at the peak of a roof is 135 degrees. Calculate the measure of the angle formed by the rafter in the king post. So here's a king post, here's my rafter. So finding the measure of the angle between the rafter and the king post, that's this right here. And you will notice that it's going to be half of this 135 degrees. So if you're making a roof, you would want to check this. If you know your roof is supposed to be 135 degrees, you can check this angle right here to make sure that you have this king post properly installed in a 90 degree. Okay, so 135 degrees divided by 2, and I get 67.5 degrees, with the angle between the rafter and the king post. Next page. So once again, you should have this already. So perpendicular lines, lines that are right angles or 90 degrees to each other. So using a protractor, determine which of the following lines are perpendicular. Now remember, human eyes are actually really good at this already. So you can probably already tell which ones are going to be perpendicular. So just taking your protractor and lining things up. So right away, I see that this is not exactly 90 degrees. So this line and this line, not perpendicular. Okay, moving on to the next one. So taking a look, this does look more like 90 degrees. And if I take a look here, oh, it is 90 degrees. So to show that these two lines intersect at 90 degrees, I will just go like this. Okay, so taking a look down here, all right, automatically, I can see that this is lined up here and this is not going to be 90 degrees. So not 90. And this one here. Here we go. Okay. Line up. And it is 90 degrees. So these two lines are perpendicular. So this line and this line are perpendicular. This line and this line are perpendicular. If we label these lines, there is a way I can write this. So let's say this is line A, this is line B, line C, and line D. Okay, so line B was perpendicular to line C. And how I show something's perpendicular is I can write it like this. So showing that we have a perpendicular angle. And we also know that line A is perpendicular to line D. There. And I probably should have had those written in your notes, but that's one way you can write it, or you can just show, for my purposes, that we have right angles by drawing a little square in the corner. Okay, last example. We have a crooked wall stud that makes an angle of 84.2 degrees with the top of a ceiling. How much must the carpenter move the stud so that it's perpendicular to the ceiling? So if I take a look, talking about the ceiling and this stud, that are apparently straight, but I cannot draw them like that. Okay, so this stud makes an angle of 84.2 degrees with the ceiling. Let's say we kind of already have it in the ceiling and we're going to move the bottom of the stud over either left or right, depending on how big or how much I need to move this. So taking a look, if this is 84.2 degrees, I need it to be 90. So I'm going to have to make this angle bigger. Okay, so if I have to make the angle bigger, I'm going to have to move this stud over this way a little bit more if I'm looking at the bottom. And how much I'm going to have to move it is, well, let's take 90 minus 84.2 degrees, and we get 5.8 degrees. So it needs to be moved 5.8 degrees over as a bigger angle. So not a smaller angle, it needs to be a bigger angle. So it's acute right now, it needs to be a right angle. So I can move bottom of the stud left in my diagram, by 5.8 degrees. Okay. And that's it. So you can start your worksheet.